SRT, Secure Reliable Transport Protocol, is a protocol developed by Haivision meant for the distribution of video-audio content in the form of a transport stream, SPTS or MPTS packets that are IP encapsulated and delivered through the public Internet network. The ATLaS NG uses its physical IP port for this purpose, labeled IP control. The first step to receive SRT traffic is to set up the type of handshake used between the transmitter and receiver of the stream. We can do this by dragging the left menu to the center and opening the mode field. Here we find three options. Caller. The ATLaS NG is a device initiating the handshake. We will need to input the listener's IP address and UDP port number. Listener. The ATLaS NG acts as a listener and therefore the user will need to input the ATLaS NG's IP address and UDP port number into the menu of the device acting as a caller. The ATLaS NG will be waiting for the connection to be initiated by the caller. Rendezvous. Either device can initiate the handshake and therefore both need to be set up with the other device's IP address and UDP port number. The second step is to define whether the IP traffic received is encrypted, which can be stated in the same menu in the encrypted field. If the content is encrypted, you will need to input the corresponding password in order to de-encrypt it, decode the video and audio services, and see all the relevant measurements. As for measurements, you can find the following tools by pressing on the triangle icon in any of the screen panels. Video audio parameters, loudness audio analyzer, transport stream analyzer, SRT measurements. These are metrics specifically related to the SRT traffic and protocol. Here we can see that the panel gets divided into two areas. Upper area showing 4 plots. Bandwidth plot, it gives us an estimation for the available free bandwidth in the network. RTT plot, round trip time divided in half. The round trip time is defined as the time required for a packet to go to destination and come back to the source. Received rate plot, bandwidth used by SRT traffic. Received buffer plot, receiver's buffer load measured in bytes. Lower area showing several numerical metrics, the most relevant being packets lost, packets that have not been received and should have. The receiver expects them as each packet is identified by a sequential number. Packets dropped, packets that arrived at the receiver but were discarded for several possible reasons, such as being corrupt or having been received too late. Packets ACK sent, number of packet reception acknowledgements sent back to the streamer. SRT sends ACKs every now and then, instead of for every single received packet, in order to reduce the network congestion. This is the reason why the number of ACKs is significantly lower than the number of packets received. Latency. This is a time negotiated between caller and listener as to define the maximum time to wait for a packet before discarding it.